Hey guys, so this is our 4.0 lesson in our Pure Substances and Mixtures unit, and today we're going to talk about concentration and solubility. So solubility, just think of when substances are dissolving in a solvent, the particles of the solute mix between the particles of the solvent, and this is otherwise known as diffusion. The mass of the solution changes, but the volume stays the same. So if you see these particles on the left, before diffusion, you can see the particles are not mixed, but after diffusion, the particles have mixed together. So that is diffusion. So in terms of solubility, you also have to consider that some particles are polar, which means that they have charges, and some are nonpolar, which means they don't have charges. So polar molecules include water, sugar, and salt, and an example of some nonpolar molecules are oil and gasoline. So as you can see here, this is some splashing oil, and this is splashing water for those of you who are visual. So just think of water, sugar, salt as polar, and oil and gasoline as nonpolar. And there's obviously more examples for those of you who are like, oh. So if you're deciding if substances will dissolve together, you need to follow the rule like dissolves like. So just think back here, I said water and sugar are polar molecules. So I have water and sugar on this slide because this means that polar solvents will only dissolve polar solutes and non-polar solvents will only dissolve non-polar solvents. So what that means is that sugar will dissolve in water, but it's not going to dissolve in oil. So hopefully that gives you a little bit of a visual there. So sugar is polar and it will dissolve in the polar water, but it will not dissolve in the oil because it is non-polar. And also, if a solute can dissolve in the solvent, we say it is soluble, okay? So we know that if sugar can dissolve in the water, it is soluble. If a solute is unable to dissolve in a solvent, we say it is insoluble. So now we're going to talk a little bit about concentration. I always think about juice when I think of concentration. The concentration of a solution tells us how much solute is dissolved within the volume of that solution. So what that means is a concentrated solution has a lot of solute particles given the volume of the solution, and a dilute solution has a small amount of solute particles given the volume of that specific solution. For example, if one solution has 10 grams of sugar dissolved in it and there's 100 milliliters of water, and the other solution has 50 grams of sugar and 100 milliliters of water, the first solution, so this one that has the 10 grams of sugar, is actually more dilute because it has less sugar. And the second solution with the 50 grams of sugar is more concentrated. So although these look the same, this one would be more dilute because it has less sugar, and this one would be more concentrated because it has more. We can also calculate concentration. So concentration, the formula is C equals M over V. So the mass of the solute in grams over the mass of the solvent in milliliters. Please take note of your unit of measure. So grams and milliliters, okay? So quickly on your own, try it. Calculate the concentration if 6 grams of salt are dissolved in 200 milliliters of water. I'll just flick over to the formula for you. So grams and milliliters. So we have 6 grams of salt. So the mass of the solute is 6 grams. And we're going to dissolve it in 200 milliliters of water. So concentration here is 6 over 200. And you have to make sure that you have your correct units of measure. So C equals M over V, and that equals 6 grams over 200 milliliters, which equals, hopefully you got it, 0.03 grams per milliliter. And again, don't forget your units. It's very important not to forget grams per milliliter. The concentration of the solution, therefore, is 0.03 grams per milliliter. Next, we're going to talk about saturated versus unsaturated solutions. So a solution in which no more solute can be dissolved, that is when it's called saturated. So eventually it gets to a point where you cannot add any more sugar. A solution in which more solute can be dissolved is called unsaturated, okay? So just think of it, if it's saturated, we can't add anything else in there. Nothing further can get dissolved. If it's unsaturated, we can still add more. The solubility of a substance is the measure of how much of the substance can dissolve in a certain solvent at a certain temperature. So as you see in our speedy experiment, the temperature of the water is definitely a variable in how fast something will dissolve. So just think of this: solubility is the maximum amount of solvent that will dissolve in grams divided by 100 milliliters of that solvent at a certain temperature. So for example, in water that is 20 degrees Celsius, the solubility of sugar is 206 grams for every 100 milliliters. And the solubility of salt is 36 grams for 100 milliliters. So as you can see, sugar is a lot more soluble. You can get a lot more sugar in 100 milliliters than you can salt. You're free to try this on your own as well, provided you have excess of these at home, just to try it out. So I'm going to get you guys to try it now. And as a formula, not an experiment. So 9.3 grams of baking soda will dissolve in 100 milliliters of water. What is its solubility? I'm going to give you a little bit of time here. So just think 9.3 grams and 100 milliliters of water. So remember, solubility equals M over 100 milliliters, which is the mass, 9.3 grams divided by 100 milliliters, which equals 0.093 grams per 100 milliliters. And it's nice that we have 100 here, so it's just simply just hopping it over 2 decimal places. So if you were to answer this in a quiz form or anything like that, you'd say the solubility of baking soda is 0.093 grams for every 100 milliliters. So these are the important formulas from today, and I really encourage you to practice some additional ones on your own. And remember, with hundreds, you're just going over 2 decimal places, so it's usually quite simple, but I hope that you have enjoyed today's lesson, and make sure you practice and put some notes in your unit binders.